When we look up at the universe, we see these incredible, breathtaking images, just pure cosmic art. But what if I told you some of these pictures aren't just art? What if they're more like a crime scene? Well, today we're opening up the case file on one of the most famous images in all of astronomy. Oh, yeah, you've seen this one for sure. The Eagle Nebula. It's home to those iconic pillars of creation. I mean, it's the textbook example of a stellar nursery, right? A place where new stars are born. You see the glowing gas, the dark, looming pillars of dust. It's a total masterpiece. But here's the thing. We need to completely shift how we're looking at this. It's not just some static portrait hanging in a cosmic gallery. No. It's a scene, frozen in a moment in time, capturing the aftermath of some really dramatic and violent events. That beauty is hiding a seriously chaotic history. Yeah, the peaceful vibe this image gives off, it's totally deceiving. Behind it, there's a story of intense energy, of stars literally brawling with each other, and massive stars getting thrown clear out of their own home. So our investigation has one big question. What really happened here? Okay, so our official crime scene is designated Messier 16, or M16 for short. It's about 5,700 light years away. And right at the heart of it all, we have our main person of interest, a brilliant young star cluster named NGC 6611. This cluster you'll see is the engine that's driving everything we're about to uncover. So to crack this case, looking at it in just visible light isn't going to cut it. We need to see deeper, with a whole different kind of vision. We've got to look for the fingerprints of high-energy activity. And that, my friends, brings us to our very first clue, the X-ray evidence. Our first tool is NASA's CHANDRA X-ray telescope. You can think of it like our forensic scanner. It slices right through all that gas and dust to detect the high-energy X-rays that are just blasting out from the young stars inside NGC 6611. And wow, did it find a lot. Over 1,700 X-ray sources, with more than 1,000 of them almost certainly belonging to the cluster itself. Okay, now here's where it gets really interesting. Scientists took these young stars and sorted them into two basic groups. You've got your disk-bearing stars. These are the ones still surrounded by those dusty, planet-forming disks they were born from. And then you have the diskless stars, the ones that have already lost all that material. And boom, here's where the first big clue drops. The research found that the stars still holding onto their disks were actually less active in X-rays. I mean, that's completely backwards, right? You'd think the stars with all that stuff swirling around them would be way more chaotic, but they're not. This tells us something really important is going on with the stars that have already lost their disks. And you can see it perfectly right here. On the left, those are the 219 disk-bearing stars, kind of clumped together. But look at the right, nearly 1,000 diskless stars. And they are spread out all over the place. The naked stars, the ones already stripped of their planetary nurseries, are by far the dominant population here. So what does this all mean? The crucial takeaway is that the environment in NGC 6611 is incredibly harsh. The intense radiation and high-energy activity from the stars themselves are basically sandblasting the planet-forming disks right off their neighbors and maybe even off of themselves. It's like a self-destructive nursery. But all that high energy is only part of the story. To really understand what happened here, we also need to track the movements of our suspects. And this brings us to clue number 2, the kinematics, the science of how things are moving. For this part of the investigation, we bring in a different tool, the Gaia satellite. So if Chandra was our forensic scanner, Gaia is our motion tracker. It measures the exact positions and speeds of billions of stars, which lets us essentially rewind their movements and see exactly where they came from. And Gaia revealed something truly fascinating. NGC 6611 isn't one big happy family. It's actually two. There's an older, more spread out generation of stars that are about 7.5 million years old. But then, way more recently, a younger, much more tightly packed group was born just 1.3 million years ago. And this group, this is the one that contains the cluster's biggest, baddest, most massive members. But here is the absolute bombshell from the Gaia data. Get this. More than half of the cluster's most massive members, we're talking giant, scorching hot O-type stars, they aren't just orbiting peacefully, they're being ejected, kicked out. These are what astronomers call runaway stars. They're moving so fast that they're literally escaping the cluster's gravity for good. And when we trace their paths backward, they all come from the dense center of that younger population. Their ejection happened recently, too, within the last couple of million years.
The cause? You guessed it, violent gravitational wrestling matches between these massive stars.
So this just deepens the mystery, right? We look at this gorgeous, serene nebula, but all the evidence shows that its central cluster is acting like a cosmic slingshot, just flinging its most massive members out into space. Why? What is going on?
All right, it's time. Time to put all the pieces together. We've got the X-ray evidence telling us about a harsh, disk-destroying environment. And we have the kinematic evidence of massive stars being violently ejected. Let's see how they solve the case.
Let's review our case file. The X-rays, they told us the environment is insanely intense, stripping stars of their disks. The kinematics, they told us the cluster has a history of violent gravitational brawls, powerful enough to eject more than half of its biggest stars. Both of these clues are pointing to the exact same thing: pure chaos. There's really only one conclusion that fits all the evidence we have. The calm, relatively spread out cluster we see today, well, it's just a shadow of its former self. To create that much X-ray damage and to eject that many massive stars, NGC 6111 had to have been born far, far more compact and densely packed than it is now. So we've solved the mystery. But what does it all mean? Well, it means we can finally tell the real story of this star factory. We can finally go from just seeing a static picture to understanding a dynamic, incredible evolutionary process. Here's how it all went down. First, that most recent generation of stars formed incredibly close together, packed into a really dense core. Second, being so close to each other led to what we call dynamical chaos, where the massive stars gravitationally interacted, kind of like billiard balls on a cosmic table, flinging each other out into space. And third, after ejecting so much of its mass, the cluster expanded over the last million years or so into the more peaceful-looking state we see today. And this is why it all matters. The Eagle Nebula isn't just some pretty picture to hang on your wall. It's a vital cosmic laboratory. It's giving us a perfect snapshot of a fundamental process in our universe, the violent and chaotic teenage years that massive star clusters have to go through before they can mature. So the next time you see this iconic image, don't just see the beauty, see the evidence, see the history, and remember the chaotic, wild story it's telling us about how stars and the clusters that build them truly evolve. It really makes you wonder, doesn't it? I mean, if this much drama is hiding behind one of the most famous images in the sky, what other incredible cosmic stories, what other violent histories are hiding out there in plain sight, just waiting for us to find the right clues?